When we use our calculators to evaluate logarithms, basically our calculator does two types of logs. It does the common log, which is base 10, and the natural log, which is base e. But what about other bases? For example, if I ask you to evaluate log base 2 of 8, hopefully that's a logarithm that you don't need your calculator for, because you're thinking 2 to what power will give me 8? And you can say, oh, I know that this logarithm is equal to 3, because 2 to the third power is 8. However, if I give you log base 2 of 9, you're asking yourself 2 to what power will give me 9? That's not one that I can come up with an exact answer for in my head. I know what I expect it to be, a little bit bigger than 3, but is it 3.1? Is it 3.01 or 3.12? We know that this is going to be a decimal answer. We want to be able to evaluate a logarithm like this one. However, it's base 2, and our calculator only handles base 10 and base e. So the question comes up, how do we deal with a logarithm such as this one that has a base other than 10 and e? And this is where we can use a property that's called the change of base property, or the change of base rule. So we're interested in evaluating log base b of m, where the base b is a number other than 10 and other than e. So for right now, let's go ahead and just say we don't know what this equals, so we'll equal it to x. And let's take this logarithm and rewrite it in exponential form. So the base of the logarithm is currently b, so that would be b to the x power is equal to m. Now we know from algebra that if we do one operation to the left-hand side of the equation, that's okay as long as we do the same operation to the right. So we're going to actually take the log of both sides of this equation. So when I say take the log of both sides, I'm choosing just base 10. We could choose really any base that we want to. I'll choose base 10 because our calculator handles base 10 nicely. So taking the log of both sides gives us log of b to the x power equals the log of m. Now use your properties of logs that allows us to take the exponent and rewrite it out in front as a constant being multiplied by the logarithm. So now I have x times log of b equals the log of m. And then just finish this up solving for x. We can divide both sides by the log of b. So dividing out the log of b on the left-hand side gives us that x is equal to the log of m divided by the log of b. So now go back to the very beginning. What were we trying to find? X was log base b of m. So what we have just concluded, therefore, we're saying that log base b of m is actually equivalent to log of m divided by the log of b. So what that is saying is if you have a base b, some base that you don't care to deal with, you can actually turn it into a base 10 logarithm if you divide the log of the argument divided by the log of the base. And this is your change of base property, or your change of base rule. Now, interestingly enough, when I go back up to the derivation here, notice that I chose to take the log of both sides. Let's talk about what would have happened if we had chosen to take the natural log of both sides. So, if I go back to my problem, rather than taking the log of both sides, let me replace it, instead of log base 10, let's try natural log. So taking the natural log of both sides gives me natural log of b to the x equals the natural log of m. I can still use my property of logs that lets me take that exponent and rewrite it in front as a constant being multiplied by the natural log of b. And then I go ahead and solve for x by dividing by the natural log of b on both sides. So the natural log of b's divide out. I get x is equal to the natural log of m divided by the natural log of b. So now, adding that on to my change of base rule, then this is saying that the log base b of m could also be written as the natural log of m divided by the natural log of b. So I can kind of expand my bubble here. Once again, look what you're really doing. You're dividing the log of the argument, which was m, and you're dividing that by the log of the base. So the way this is written right now, it's the natural log of the argument divided by the natural log of the base. So the first way we did it, it was log base 10. Second way we did it was natural log. It turns out that it's a base of your choosing. You could choose any base that you want, as long as it's the same base in the numerator and the denominator. These are the most common too, because these are the two bases that our calculator can handle easily. You have a log button, and you have a natural log button on your graphing calculator. So this is your change of base rule. This allows you to change any base into either a base 10 or a natural log. And that'll allow us to get some decimal approximations using our calculators.